Okay, we're looking at problem 30 from page 136 in lesson 2-8. You have a painting that is 30 inches wide and 22.5 inches tall. You would like to reproduce it on a sheet of paper that measures 8.5 by 11 inches, leaving at least 1-inch margins on all four sides. What scale should you use to keep the sheet of paper in normal upright orientation? Assume the reproduction will be as large as possible. So here, I've written it out. Here is my picture. It's 30 inches by 22.5 inches. And here's my paper in upright position. So you know when you write on your paper, it's 8.5 inches by 11 inches. And my 1-inch margin makes it really 6.5 inches by 9 inches. So I have 6.5 inches. I'm going to leave the inches off. By 9 inches. And I want it super duper close to 30 inches over 22.5 inches. I'll put it there since I put it there. Okay, so first of all, notice that here I have my larger number up top, and here I have my smaller number up top, and that's just because of the different orientation. So one thing that we have to realize is that these two things are not going to be equal. I just want to make sure that my picture, I can reduce it so that it stays inside of my paper. So my paper, these are the limits right here. These are the limitations of my paper, my sheet of paper. So I just want to make sure that my numbers come as close as possible to this 6.5 inches and this 9 inches. So for me, I use my calculator a lot. So let's use the calculator. We have, first of all, this is important. This ratio here is 1 1/3 or 1.33. So that's something that we need to know because we know our next ratio when we reproduce it needs to be 1 1/3 also. So I'm looking for the factor. I'm reducing this. I'm going to be dividing by numbers. And so first I looked at this 9 and this 22.5. And I got 22.5 divided by 9 is 2.5. Okay, so 2.5. If I divide 30 by 2.5, I get 12. Well, 12 will not fit on this paper. If I divide this by 2.5, if I divide both of them by 2.5, I get 9, and then I get 12, and that's way too big. So I'm going to look at the top number instead to see if I can get something closer. So we'll do 30 divided by 6.5, and I get 4.6. 4.615. So instead, let's do 4.6. So the first scale factor that I'll use to test is 4.6. So if I divide 30 divided by 4.6, I get 6.52 up top. So 6.52, which is too big, but we're just using it to see what we have. And let's do 22.5. And I get 4.89, which is not too big because it still falls into the range of that 9. But this is too big. So let's go up one. Let's do 4.7 now. So if I divide both top and bottom by 4.7, let's see what we get. So let's see, 30 divided by 4.7 is 6.38. So that's within my parameter. So 6.38, this is my factor. And 22.5, I get 4.79. So those again are within my parameter. Let's see if I can get a little closer. So I see that 4.6 is too small, and 4.7 is just right. Let's try 4.8 to see what we get. So 30 divided by 4.8 is 6.25. So we'll come over here, 4.8, 6.25. I want it as big as possible. So this 6.38 is already bigger. Let's just, for the heck of it, test the 2.25. I get 4.68 or 4.69, sorry. And so far this 4.7 is the best. Let's try in between this 4.6 and 4.69. Let's try 4.65. So 30 divided by 4.65 is really, really close. It's 6.45. And 22.5 is 4.83. So far this is the biggest and the closest. So my scale factor for the first one, if I want to keep it in the upright position, would be, a scale factor of 4.65. Let me erase some of this now. All right, so for A, the best one would be 4.65. Now let's look at B, and if I turn it this way. So I want to know the best way if I turn it this way. And so this time it would be 9 inches over 6.5 inches. And I want to get it super duper close to 30 inches over 22.5 inches. And I'm sorry, I forgot to verify that my 4.65 came out to a ratio of 1 1/3. Please go back and do that for yourself so that you can make sure that it comes out to that ratio. Okay, so again, this time I'm going to go ahead and do up top because my larger numbers are up top. So we'll do 30 divided by 9. And I get 3 1/3. So if I do a scale factor, and this is just a test, so if I divide everything by 3 1/3, I know for the top one I'm going to get 9. So this is 3 1/3. The top one I get 9. And at the bottom, let's see, 22.5 divided by 3.333, which is 3 1/3, is 6.75. And that's too big. So it can't be that one. So if it's not 3 1/3, let's try 3 2/3. Okay, so if I divide 30 by 3 2/3, which is 0.666667, it's 0.818. 8.18, sorry. And if I divide 22.5, I get 6.13, which is pretty close. Okay, let's see if I can get even closer. Let's try 3.5 as my scale factor. Let me underline those so we're not confusing ourselves. Let's see, so 30 divided by 3.5 is 8.57. Oh, we're getting closer. And 22.5 divided by 3.5, 6.43. So this one is closer, so we're not going to use that one. This one is closer. Let's try to get even closer. Let's try 3.75 this time. So let me do blue this time. So 3.75, or 3 3/4. So 30 divided by 3.75, get 8. We can stop there because that's less than. So we've gone too far. So let's try 3.6 instead. Just to see. So 30 divided by 3.6, 8.33. This is still bigger. So 3.5 is about, I'm sure we start when we're dealing with decimals, there are infinitely many numbers, but we'll say for us that the closest would be a scale factor of reduction, of course, a scale reduction of 3.5. So I will reduce each one by a factor of 3.5, divide both of them by 3.5, and I should get the best or the biggest reproduction. I certainly hope this helps.